Good day, this is Basic Calculus, and today we'll be talking about finding the extreme values of a function on a defined interval. Let's review first the extreme value theorem. So it states that if a function f is continuous in a closed interval from a to b, then f of x has the highest point called the absolute maximum value. Likewise, it also has a lowest point called the absolute minimum value. And both values are called extreme values. Now, we have also learned that there are a number of ways on how to find the extreme values of a function on a defined interval. First way is by graphing the function, of course. Second is by table of values, and third is by following a four-step computation. Graphing and table of values as ways to find the extreme values of a function is already discussed on the reading material, so please read the PDF and your weekly learning packets. In this video, we will just be talking about following a four-step computation to find the extreme values of a function in a defined interval. Now let's have our first example. We have here identify the absolute extreme values of f of x equals x squared defined on the closed interval from -2 to 3. So step 1. Find the first derivative of the given function. So our given function in our example is f of x equals x squared. So we will find the first derivative of our function. So we have here f of x is equal to x squared. F prime of x is equal to 2x. So that is your first derivative of your function. Step 2. Set the first derivative equal to 0 and solve for the critical value. So we have here, in step 1, we came up with f of x equals 2x. So for step 2, we have to set our first derivative to 0. So that would be 2x equals 0. So solve for x, divide both sides by 2. Okay, x is equal to 0. So that is your value of x. Now, that x equals 0 is your critical value. Step 3. Use the critical value and the endpoints of your interval to test for any absolute minimum or maximum values. So we will take first the critical value, the result of our step 2. So we have here x equals 0. So we will solve for f of 0. Okay, f of 0, we will go back to our function. Our function is x squared. F of x equals x squared. So f of 0 will be equal to 0 squared. F of 0 is 0. Next, we are done with evaluating our function, okay, using our critical value. So we will go now to the endpoints of our interval. So first we have -2, it's here, -2. So we will have f of -2, that's equal to -2 squared. So f of -2 is 4. And we have 3, so f of 3 is equal to 3 squared. F of 3 is equal to 9. Step 4. Compare the three values of f of x from step 3. Okay, so we have here f of 0 is equal to 0, f of -2 is equal to 4, and f of 3 is equal to 9. So among the three values of f of x, okay, first find which among the three has the highest value. Of course, it's 9. So our absolute maximum value is 9. That is when x is equal to 3. So our absolute maximum is at 3, 9. Meaning to say, when you graph the function f of x equals x squared on the closed interval from -2 to 3, the highest point on that interval is at 3 and 9. And for the absolute minimum value, okay, go back to your results in step 3, find which value of f of x is the smallest value. So we have here 0. So your absolute minimum value is 0. That is when x is equal to 0. So your absolute minimum is at the origin. So meaning to say, in your graph, f of x equals x squared, on the interval from -2 to 3, the lowest point on the graph is at the origin. Now let's have our second example. Identify the absolute extreme values of f of x equals 3x squared minus 12x plus 5, defined on the closed interval 1 to 4. So step 1, find the first derivative of the given function. So the given function is f of x equals 3x squared minus 12x plus 5. So f prime of x is equal to 6x minus 12. So that's already our first derivative. Step 2, set the first derivative equal to 0 and solve for the critical value. So we have here 6x minus 12 equals 0. It would be 6x equals 12. X is equal to 2. So highlight, x equals 2 is your critical value. Step 3, use the critical value and the endpoints on the interval 1 to 4 to test for any absolute maximum or minimum values. So let's start first with x equals 2, so we will have f of 2. Okay. But let's go back to our given function first. Our given function is f of x equals 3x squared minus 12x plus 5. So let's write that so we'll not be confused. So f of x is equal to 3x squared minus 12x plus 5. So f of 2 is equal to 3 times 2 squared minus 12 times 2 plus 5. So f of 2 is equal to 3 times 4 minus 24 plus 5. So f of 2 is equal to 12 minus 24 plus 5. So that would be negative 7. So that is your f of 2. So you highlight. Next, let's have 1. Okay, so we have here f of 1 is equal to 3 times 1 squared minus 12 times 1 plus 5. F of 1 is equal to 3 minus 12 plus 5. F of 1 is equal to -4. Alright? And next, okay, let's highlight that first. Next, let's have f of 4. So f of 4 is equal to 3 times 4 squared minus 12 times 4 plus 5. So we have f of 4 is equal to 3 times 16 minus 48 plus 5. F of 4 is equal to 48 minus 48 plus 5. So we have here f of 4 is equal to 5. Highlight. Okay. So step 4, we have to compare the 3 values of f of x. Okay. So comparing, we can see here that our absolute maximum value again is the value of f of x that has the highest value, of course. So we have here 5. So our absolute maximum value is 5. That is when x is equal to 4. So our absolute maximum is at 4 and 5. And the absolute minimum is -7. So our absolute minimum value is -7. That is when x is equal to 2. So your absolute minimum is at 2 and -7. So that's it. Those are your absolute maximum and minimum values of f of x equals 3x squared minus 12x plus 5, defined on the interval from 1 to 4. Example 3. Find or identify the absolute extreme values of f of x equals x cubed minus 6x squared plus 8, defined on the closed interval from -1 to 5. So step 1, find the first derivative of the given function. So we have f of x equals x cubed minus 6x squared plus 8. So f prime of x is equal to 3x squared minus 12x. So that is our first derivative. Step 2. Set the first derivative equal to 0 and solve for the critical values. So we have here 3x squared minus 12x equals 0. Factor the left side of our equation. 3x is a common monomial factor, so we have 3x times x minus 4 equals 0. So solving for our critical values, let's take first our first factor. So we have 3x. So 3x equals 0. That is equal to 0. So, right? And next, take our second factor. We have x minus 4. So you have here x minus 4 equals 0. So for x is equal to 4. So that is also our critical value. So we have two critical values for this problem. So step 3, use the critical values and the endpoints on the interval to test for any absolute maximum or minimum values. So let's have first x equals 0. Now let's be reminded of our function. Our function is x cubed minus 6x squared plus 8. So let's write it. F of x is equal to x cubed minus 6x squared plus 8. So let's have first x equals 0 when x equals 0. So you have f of 0 is equal to 0 cubed minus 6 times 0 squared plus 8. So f of 0 is equal to, of course, 8. Next, let's have x equals 4. So we have here f of 4 is equal to 4 cubed minus 6 times 4 squared plus 8. F of 4 is equal to 64 minus 96 plus 8. So f of 4 is equal to negative 24. Okay. Next, let's have our endpoints of the interval. So we have here negative 1. So f of negative 1 is equal to negative 1 cubed minus 6 times negative 1 squared plus 8. So f of negative 1 is equal to negative 1 cubed is negative 1. Okay. Minus 6 times negative 1 squared is positive 1 plus 8. So f of negative 1 is equal to negative 1 minus 6 plus 8. So f of negative 1 is equal to 1. And let's have 5. So we have f of 5 is equal to 5 cubed minus 6 times 5 squared plus 8. F of 5 is equal to 125 minus 6 times 25 plus 8. F of 5 is equal to 125 minus 150 plus 8. So f of 5 is equal to negative 17. Okay. So we are done now with step 3. Now let's move on to step 4. So in step 4, you compare the 4 values of f of x. Okay, in step 3. So let's write first the absolute minimum and absolute maximum. So the absolute maximum value is Okay, 8 when x is equal to 0. So the absolute maximum is at 0 and 8. And absolute minimum value is equal to negative 24 when x is equal to 4. So the absolute minimum is at 4 and negative 24. So that's it. That's how to find the absolute maximum value and absolute minimum values of function on a defined interval using the 4-step computation. Hope you learned something and see you in our next video.